to walking you through the foundations of compute, storage, and database services which make up the core of any migration to the cloud. They're also great services if you're looking to deploy new workloads in the cloud. So let's continue with learning more about AWS. AWS offers three types of compute options at the fundamental level. We have the virtual machines, and then we have container services and serverless compute. In this first section, we're going to be talking about compute, and really to talk about compute, the first thing that we need to address is Amazon Elastic Compute Cloud, or EC2. Amazon EC2 is a web service that provides secure and resizable compute capacity in the cloud, allowing you to provision virtual servers called Amazon EC2 instances. This allows you to deploy or migrate workloads directly from your on-premise infrastructure into the cloud. EC2 supports Linux and Windows and Mac OS in select regions. It is an extremely flexible service that gives you complete control over your service. However, in order for us to understand what a virtual server like EC2 is, it's helpful for us to get a basic idea of what a server is. When you think about your on-premise infrastructure, you've purchased physical equipment or servers. At the most basic, servers are made up of CPU for processing, memory for temporary data storage, disk for long-term storage, and networking to allow remote access. What you're seeing here is the physical host, the physical device that underpins a compute environment. When you deploy a physical server in your environment, you have access to all the resources, which is great. However, often you will only use 10%, 20%, maybe even 30% of that resource, which means a large portion of it is going to waste sitting idle. Resources you've paid for, but are not actually utilizing. EC2 is a virtual server. What this means is that when you deploy an instance of EC2, you can deploy only the size you need and change it when you need to. As you can see here, you can deploy an EC2 instance, which consumes only the resources you need. You choose the amount of CPU and memory and then create separate disk volumes using the service Amazon Elastic Block Store, or EBS. We'll speak more about this later. Once the EC2 instance is deployed, you can then run your applications or workloads on them in a similar way to your existing environment. However, using EC2, we have the ability to add, remove, pause, resume, change, scale, or manipulate your instances as you will. There are different sizes and types of EC2 to help you run your workload as efficiently as possible. Now that we know what EC2 is, what are some of the distinct benefits? Let's start with elasticity, the ability to scale your application as the demand changes. As an example, let's say you're running a web server. Under normal load, you expect there to be 100 users connected to your application around 12 p.m. As the day goes on, that number really starts to dwindle off, and now you're down to a baseline of, let's say, around 10 users in any given hour or any given minute. But what happens if we go above the 100% we were expecting? We now have the ability to increase the number of instances that serve the web traffic. We can go up to 200 or 300 or 3,000 concurrent users if the need be, by increasing the number of resources under the hood. With the EC2, there are various different features built into it that give us the ability to scale up or scale down, in or out, so we can take advantage of that pay-as-you-go pricing that we talked about earlier. The second one here is control. We have the ability to stop and start instances, or pause and resume for certain supported instances as we need them. Again, that has a price benefit for us, the ability to save on cost. When we don't need our instances to be running, we can scale down. But then it also gives us the ability to size our fleet appropriately to the amount of traffic. EC2 gives you the flexibility to choose what you want when you need it. There are a number of different EC2 instance types and families, which we'll talk about in a moment, but you can pick the right type of instance for the right type of job. EC2 is nicely integrated with other services, which enables you to create secure, scalable, and highly customizable environments. There are a number of other benefits to EC2, including reliability, security, which we'll touch more on later. It is inexpensive in terms of you can pick the right type of instance for the job, whether it is a small or large instance with different resources matched to the workload specifically that you have for EC2. A key feature of EC2 is something known as the Amazon Machine Image, or AMI. This allows us to select the operating system of choice and even have custom applications pre-installed to speed up deployment time. To summarize, EC2 provides you the flexibility to run your workloads when and how you want to. EC2 is what you make it. Example, a web server, or an application server, or a database server. Thinking of EC2 as disposable allows you to take advantage of pay-as-you-go pricing, significantly reducing your overall cost. There are a large number of EC2 instance types, which is great as it allows you to deploy the EC2 instance that will be most efficient and effective for your workload. The instance types are grouped into instance families, which make it easier to understand what each type is best used for, allowing you to make an informed decision. If you want to reduce the overall cost of your workload, then choose a general purpose instance. You need more compute grunt to help process application requests or batch processing quickly? Choose a compute optimized instance. If you need more memory to help speed up your database, choose a memory optimized instance. What if you're interested in machine learning, 3D modeling, or inferencing? Choose an accelerated computing instance. Each instance type also comes in different sizes, allowing you to be as cost efficient as possible while still getting your work done within your committed service level agreement. We previously learned that flexibility was a great benefit of EC2, and pricing flexibility is no different. With multiple pricing options to fit your workload and environment, we give you the options to make the decision and configuration that is right for you. On-demand instances can be considered the list price. With on-demand, you have the greatest flexibility and control over when and how you configure and deploy your instances. This is great for immediate scalability, workload changes, temporary workloads, or workloads that cannot be interrupted but required to be run only for a short amount of time. Reserved instances, on the other hand, give you a significant price reduction for workloads that run permanently. For example, you can choose a 1 or 3-year commitment, and the more you pay the commitment upfront, the bigger a discount you will get. Great for steady state workloads. Example, your public-facing website. Savings plan are a similar concept. You can commit to a certain amount of capacity that you are going to utilize over time. And lastly, and probably the most interesting one here, is spot instances, which gives you up to 90% of the on-demand pricing with one caveat. Spot instances are not guaranteed to run permanently. This means you need to be strategic about how you deploy them. However, they are great for ultimate cost reduction. As an example, most stateless applications can use spot instances and benefit from the lower cost. Another thing that's great about EC2 is the per-second billing with Amazon Linux, Windows, and Ubuntu, and per-hour billing with all other operating systems. This leads to granular billing, which is great for cost management. Another concept that I want to introduce here is the concept of unmanaged versus managed services. With unmanaged, you need to manage the scaling, the fault tolerance, and availability on your own within your application or architecture. Keep in mind, if you were running this application on premises, you'd be managing this anyway, including managing the physical infrastructure. But one of the key advantages to some of the services we're going to talk about here is that there's actually a managed, or in some cases, a fully managed option where you don't have to worry about the scaling, the fault tolerance, and the availability, which are built into the service itself. We're now going to shift gears a little bit and talk about serverless computing, which is something you may have heard of. EC2 is great. It's extremely powerful, configurable, flexible, and gives you control over your application and how it runs, but with that power comes responsibility. You still have to manage the fault tolerance, high availability, scalability, the operating system, application patches, access, permissions. It is a full server. But maybe you don't want to worry about the administrative side of compute. You just want to run some code. Maybe you have an application where some parts get run frequently and other parts not so much. Maybe you have ad hoc calculations that need to be run, or reactionary code that responds to events in your environment. Having a full server sitting there idle, waiting to be interacted with, is quite a waste of resources. So how can we do this better? We have serverless computing. With serverless computing, you have the ability to build and run applications and services without provisioning or managing the service that we just talked about. So we can still get the outcome of running specific code or function without having to manage all the underlying components. A key benefit here: no service to provision or manage, which leads to never paying for idle resources. So this is where serverless can greatly help us. If we can run our applications in a serverless manner, we can actually save by never paying for idle resources. So now that we've talked about what serverless computing is, let's talk about the heart of serverless technologies, AWS Lambda. AWS Lambda is a fully managed compute service which runs stateless code, supports multiple different programming languages, and can run your code based on a trigger or a schedule that you choose. This gives us some great benefits. Previously, we talked about EC2 instances, which required us to provision or choose the right type of instance to run our application, the network, and so on. With Lambda, we just need to add a code to something called a Lambda function and then tell it when to run. Lambda manages the execution and completion of the code. You don't have to worry about deploying the infrastructure or anything. AWS Lambda particularly excels at executing short-running, stateless code that has a defined start and finish. For code that runs indefinitely, you'll want to stick with something like EC2, but a little cloud design allows you to take advantage of what AWS Lambda has to offer. AWS Lambda also helps us to add automation into an environment, whether it's automatic logging, response and remediation, instant management, analysis. The list is just endless. Let's have a look now at an example of using AWS Lambda. We're going to have a basic scenario where a user could upload a picture to a storage location, in this case, an S3 bucket. We'll learn more about that in the storage section coming up. We want to do some image recognition when the image lands in the bucket, so we invoke AWS Lambda to use an image recognition service when this occurs. So in this example, a user uploads a picture to S3, S3 triggers the Lambda, and Lambda uses another service to perform image recognition. Then it stores the results in a text file back in the S3 bucket. We call this an event-driven architecture where there are no active servers running. Let's take a look at how this is built. I'm going to be walking through an environment that has been pre-built to show you how it all ties together. We are now looking at the AWS Lambda dashboard in the AWS Management Console. From here, we can create a Lambda function. We're going to author one from scratch, give this a name of AWsome Image Recognition. We'll then select our favorite runtime. I'm happy with Python 3.9 and the ARM architecture. I'll then change my default execution role. This will give my Lambda function permission to access the images in my S3 bucket and to perform image recognition on them. So I will choose an existing set of permissions that I have already pre-configured. I'm now ready to create my Lambda function. Now that my Lambda function has been created, you'll see that I can edit my function code. It has some sample code for me to begin with. However, let's replace this by pasting in our own Python code. This code allows us to receive an image from an S3 trigger, perform image recognition, then store the results of it back in the original bucket as a text file. Once we've added our code, we can now save and deploy a function. I'll now navigate over to my S3 bucket. I'm going to edit its properties and add a trigger to invoke my Lambda function when I upload an image. I'm going to scroll over to Event Notifications, click on Create Notification and give it a name. I'll specify a .jpeg suffix, so it only runs for JPEG files. I'll also make this only trigger on new upload events. And finally, I'll select my Lambda function we just created as the destination of the event. Now we'll click Save Changes and test it out. I'm back at my bucket, and now I want to upload a photo of a delicious pan pizza I cooked the other day. It's called lunch.jpg. I'll now drag and drop lunch.jpg into my bucket to upload it. Now that it's there, you'll see it listed inside my bucket. In the meantime, this will trigger my event notification to invoke my Lambda function and perform image recognition. When I click refresh, you'll see that the Lambda function has dropped our results as a text file in the bucket too. Let's download it and see inside. And finally, I can see that it has confirmed with 99% confidence that my pizza is in fact a delicious pizza. As we saw in this example, AWS Lambda enables you to create code blocks for easy development, testing, and deployment. AWS Lambda shields us from having to create or provision any virtual service, unlike an EC2 instance, where the responsibility of provisioning and managing the virtual server is on us. There are many other serverless services within AWS that can be integrated together. Earlier we saw an example of event notification from S3. But let's see other applications and use cases for serverless. So in the example that we just saw with the Lambda, we were doing something very simple. But what if we wanted to create an entire backend? We can also do that in a serverless fashion as well. We can have many different Lambda functions and other services within AWS that will integrate with the Lambda so that we can create an entirely serverless backend. Maybe you're performing data processing or creating reports, maybe even having chatbots or other IT automation tasks, all serverless in the backend there, and we don't have any running or worst case idling resources. This is one of the key advantages of going down the serverless route. In some cases, you might not want to run a full EC2 instance 24/7 waiting for actions to occur. But what if you have a job or something that is going to take a short period of time, but maybe needs to run longer than it could within Lambda? Containers can really help us here. So what is a container? A container is a standardized unit that can package your application code and all its dependencies. The container can run on any operating system. With containers, applications can run the same on any machine without compatibility issues, with predictable behavior, and with more efficient maintenance and deployments. Containers give us a balance between the long-running compute that EC2 gives us, whilst being extremely quick to scale and run, which is where the Lambda excels. Amazon's Elastic Container Service, or ECS, is perfect for orchestrating the execution of your containers. This can be done on EC2 or even have ECS manage the infrastructure deployment for you. It maintains and scales the fleet of EC2 instances that run your containers and removes the complexity of standing up the distributed infrastructure. Typically, this is a complex activity because it requires determining where you might place those containers using a placement engine. In summary, Amazon EC2 enables us to launch as many or as few virtual servers or EC2 instances as you need, and enables us to scale up or down to handle the changes in requirements or spikes in traffic. Amazon ECS is a container orchestration service that gives us the ability to manage containers at scale on EC2. And finally, AWS Lambda is a compute service that lets you run code without provisioning or managing servers. Lambda runs your code on a highly available compute infrastructure. You only pay for the compute time that you consume when a request is made to your Lambda function. So we've spoken a lot about compute, EC2, Lambda, and ECS. Let's move on to storage on AWS. We have a number of different storage options depending on your application needs. Amazon S3, or Simple Storage Service, is a scalable, highly durable object storage in the cloud. We also have Amazon S3 Glacier for low-cost, highly durable archive storage in the cloud. And then we have Amazon Elastic File System, or EFS, a scalable network file storage service for multiple EC2 instances. We talked about hybrid cloud deployment in the previous module. With Storage Gateway, we have a hybrid cloud storage service that gives your on-premise environment access to virtually unlimited cloud storage. And then we have Amazon Elastic Block Store, or EBS, which we saw when deploying an EC2 instance. EBS volumes are network-attached volumes that provide durable block-level storage for EC2 instances. Lastly, we have Amazon FSx, which makes it easy and cost-effective to launch, run, and scale feature-rich, high-performance file systems in the cloud. Let's start with S3. S3 is an object-level storage, which means S3 manages the storage layer for you. S3 is designed for what we call 11 nines of durability. Durability is a measure of how likely you are to lose a file or an object. For example, if you store 10 million objects with Amazon S3, you can, on average, expect to incur a loss of a single object once in every 10,000 years. That's extremely durable. There is no limit to how much data you can store on S3. You can store as many objects as you like. However, each object cannot be larger than 5 terabytes in size. We previously saw an example of event triggers in the Lambda demo. This is a great feature of S3 that enables automation and designing event-driven architectures. S3 objects are stored within buckets, which are basically like containers that you create. You can also enable replication of objects between different buckets to create additional copies of the data within the same region, or maybe even to a completely different region if you need to. Then, similar to a pricing discussion before with EC2, you can also utilize different pricing models for storing your data, depending on different access patterns that you might have for your application. These are called S3 storage classes and range from immediate accessibility for hot data all the way through to archival options with long access times for cold or frozen data. Some example use cases for S3: content storage and distribution, backup and archival, storage for big data and analytics, disaster recovery, and static website hosting. In the introduction to the cloud, we spoke about AWS global infrastructure. One of the infrastructure elements that we talked about was a region, a geographical location. Now, it's important to think about which region to place your resources and store your data in. Generally, it comes down to 3 or 4 priorities. The first priority is data residency or compliance. If you have a regulatory or legal requirement that dictates where your data is kept, maybe it has to stay within the country it originated from, then you must choose the appropriate region. However, if this is not the case, then you have some flexibility to choose. Secondly, we want to locate the service as close to our customers who are going to be using it. This will help improve performance and give your customers a better experience. Third, it comes down to service and feature availability. Not all services are available globally, so sometimes you must choose a region that actually contains the service you want to use. Lastly, but by no means least, is the cost. Different regions have different prices. Sometimes choosing a different region can help you reduce costs on your workloads. Amazon Elastic File System, or EFS, provides serverless, fully elastic file storage so that you can share file data without provisioning or managing the storage capacity and performance, and it supports the Network File System version 4. With Amazon EFS, you can create a file system, mount the file system on an Amazon EC2 instance, then read and write data from your file system. We also have Amazon FSx that allows you to choose between widely used file systems such as Windows File Server and Lustre, and delivering sub-millisecond latencies and high throughput. Amazon FSx for Windows File Server provides a fully managed shared storage built on Microsoft Windows servers backed by a fully native Windows file system. Amazon FSx for Lustre makes it easy and cost-effective to launch and run the popular high-performance Lustre file system for high-speed workloads such as machine learning, high-performance computing, video processing, and financial modeling. The last service we'll talk about in this section is Amazon Elastic Block Store, or EBS. We saw how this service was being used with EC2 earlier. It provided persistent block storage to our EC2 instances. EBS volumes come in a variety of different types with different underlying physical components. This allows you to apply an appropriate volume type to your workload. For example, if you're running a database that's reliant on low latency, random access, a provisioned IOPS solid-state drive may be perfect. However, if you're more interested in streaming large log files, then a throughput-optimized hard disk drive may be better suited. The volume types also let you reduce your cost of storage. EBS volumes also support snapshots, which are backups of your volumes. These snapshots are stored in S3 behind the scenes, so you get great availability and durability of your backups. Lastly, EBS supports at-rest encryption to keep your data secure. As we have seen, AWS provides a broad portfolio of storage solutions. We have object storage with Amazon S3 and Amazon S3 Glacier to store and retrieve any amount of data from anywhere. Amazon EFS and Amazon FSx are fully managed, cost-effective file storage. And finally, Amazon Elastic Block Store and easy-to-use, high-performance block storage for both throughput and transaction-intensive workloads at any scale. Millions of customers use AWS storage services for a variety of use cases to help transform their business, increase agility, reduce costs, and accelerate innovation. Next up, let's talk about databases. Earlier, I introduced the concept of unmanaged versus managed services. While here, I want to talk about do-it-yourself databases versus AWS managed databases. You can definitely run your database of choice on an EC2 instance. There are a few valid use cases for this. Maybe you need access to the underlying operating system to install helper services, or maybe you need to use a database engine for legacy compatibility that AWS doesn't support. However, if you go down this path, you must manage high availability and fault tolerance, database backups, primary and secondary replication, operating system, and database engine patches. The administrative tasks are quite extensive. Running a database on an EC2 instance is an example of using an unmanaged service. You could instead choose to deploy your database into one of AWS's managed database services. Some examples include Amazon Relational Database Service, or RDS, for SQL-based databases, Amazon DynamoDB for NoSQL-based databases, Amazon Elasticache for in-memory caching, or Amazon Redshift for data warehousing. AWS has the broadest selection of purpose-built databases for all your application needs and allows you to scale your largest and most complex workloads so that you can grow to reach more customers. Listed here are some examples of databases that could fill your needs. For example, we have relational databases that store data with a predefined table structure and relationships between them. They're used for traditional applications such as enterprise resource planning or ERP systems, customer relationship management or CRM systems, and e-commerce. We also have key value databases that are optimized for common access patterns, typically to store and retrieve large volumes of data. They are used for high-traffic website applications, e-commerce systems, and gaming applications. In-memory databases are used for applications that require real-time access to data. They are used for caching, session management, gaming leaderboards, and geospatial applications. Document databases are designed to store semi-structured data like JSON documents. They're used for content management, catalogs, and user profiles. When choosing a database, previously it was always, we have a SQL-compatible database. This is what we use, so this is what we will continue to use, even if the use case didn't fit. Now with the cloud, you have a plethora of database options to choose from. Our first choice must be whether you want a SQL-based database or a NoSQL-based database. SQL databases are great when needing to join tables, needing to perform complex analytical queries, or to have flexible yet complex querying. Maybe you know what your data looks like, but you don't know how you want to query it. NoSQL databases, on the other hand, can be extremely fast and provide low latency responses. They support flexible, ad hoc data structures and can scale differently to a traditional SQL-based databases. So how do you choose? For a relational style database that has transactional requirements, look no further than Amazon Relational Database Service, or RDS. If you need a relational style database but require analytical processing, then Amazon Redshift is your service. For storing your data in a non-relational way for transactional databases, Amazon DynamoDB may be a good fit for those needs. But you might also have the need for a graph database, which is more focused on the relationship between data points rather than the data points themselves. You can use a graph database for fraud detection, recommendation systems, and Amazon Neptune is your graph database. Lastly, we have Amazon Elasticache, which provides a caching solution, and it's available with two popular caching engines, Redis and Memcached. This is only a sample of databases on AWS, but regardless of your application needs, there is a purpose-built option that you can migrate to or stand up in the cloud. So first up, we have Amazon RDS. RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administrative tasks. And that frees you up to focus on your application and your business. RDS supports 6 familiar database engines that you can choose from, including Amazon Aurora, which we'll talk about, Oracle, Microsoft SQL Server, PostgreSQL, MySQL, and MariaDB. Amazon RDS also provides a number of features that make it easier to manage common database tasks. Once you've created your RDS database, you can configure automatic backups and maintenance windows while working around your application traffic. By default, Amazon RDS enables automated backups of your database instance with a 7-day retention period. RDS also gives you the ability to run your database instance in a multi-AZ deployment, which increases the fault tolerance by maintaining a synchronous replica for automatic failover. Lastly, you can scale the compute resources and storage capacity needed for your database over time as your data or your demand for your database grows. We've also got Amazon Aurora, which is MySQL and PostgreSQL compatible relational database built for the cloud. It combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open-source databases. Aurora is built for high availability and durability, concepts that we are familiar with so far. It's also built for high performance, scalability, whilst providing multi-regional capabilities. There are also some neat features of Amazon Aurora that sets it apart from other relational databases. Aurora has a distributed, fault-tolerant, and self-healing storage system. The data blocks are continuously scanned for issues and repaired automatically. You can utilize up to 15 read replicas on Amazon Aurora across multiple AZs, which share the same underlying storage volume as the primary database instance. This enables really great read scaling and high availability for your applications. Another great feature is Amazon Aurora Serverless, which provides on-demand access to your data with automatic startup, shutdown, and scaling. This is another great option to save costs on those unpredictable or spiky workloads. The last thing to mention here that's important about Aurora is that Aurora is up to 5 times faster than standard MySQL databases at 1/10 of the cost. Next up, we have Amazon DynamoDB, which is a fast and flexible, non-relational database service for applications that need consistent single-digit millisecond latency at any scale. The fully managed nature of DynamoDB makes it really flexible for many different use cases, but also takes away a lot of the management tasks. DynamoDB handles all the partitioning of data in your table, so you don't have to worry about managing those different partitions yourself. You also get fine-grained access control with identity and access management. And since there's no underlying instance to manage, you configure the read and write capacity for your DynamoDB tables, ensuring that your application has the right throughput. Where you might have spiky workloads, DynamoDB features on-demand and adaptive capacity options help you with those spiky workloads. In most cases, DynamoDB offers a single-digit millisecond response time, but sometimes your application may need an even faster response time. In those cases, we have something called DynamoDB Accelerator, or DAX for short, which is an in-memory, API-compatible cache that reduces response time down to microseconds. Lastly, DynamoDB provides the ability to create a multi-region, a multi-active configuration with something called as DynamoDB Global Tables, and that frees you from having to roll your own replication solution. An example of a DynamoDB use case: companies in the gaming vertical use DynamoDB in all the capabilities of game platforms, including storing the game state, player data, session history, and leaderboards. So in summary, AWS provides over 15 purpose-built engines to support diverse data models, including relational and non-relational solutions, to enable customers to build use case-driven, highly scalable applications suited to their specific needs. NoSQL databases are purpose-built for specific data models and have the ability to support a flexible schema for building modern applications. NoSQL databases are widely recognized for their ease of development, functionality, and performance at scale. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of this session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge and make sure you complete the knowledge check after the session to see how you're progressing? Thank you for joining us in the session. Join us for our next session, Module 3, on networking and security. Thank you.